Hi there. I promised that we would work through number 12 on the worksheet. I would like to have this added to your assignment that had numbers 11, 13, and 15 on it. In number 12, it reads, a box weighing 5,400 newtons is being pulled up an inclined plane that rises 1.30 meters for every 7.50 meters of length measured along the incline. If the coefficient of friction is 0.600, determine the force applied parallel to the incline necessary to move it up the incline at constant speed. You may notice that this problem does not give us an angle, but it does give us some measurements that we can use to make an angle. So the first thing we needed to do is interpret where does the 1.3 meters go and where does the 7.5 meters go on this triangle. It says it's being pulled up an incline that rises 1.3 meters, so that means the y direction. We have a rise of 1.3 meters for every 7.50 meters of length measured not along the ground, but along the incline. So it's the hypotenuse. So 7.50 meters, and therefore our angle is the opposite side. That's the hypotenuse. So that's going to be, let's see, so ka toa, that's going to be sine. So the angle is equal to the inverse sine of the opposite side, 1.30 meters, over the hypotenuse, 7.50 meters. And that works out to be, when rounded off, 10.0 degrees. All right, let's read through the rest of the question and really draw the problem. A box weighing 5,400 newtons is being pulled up an inclined plane. Okay, so similar incline. Here's the box. It is being pulled up an inclined plane. We have an angle that we just figured out here, which is the 10 degrees. It has a weight of 5,400 newtons. Is being pulled up that way. If the coefficient of friction, coefficient equals 0.600, determine the force applied. That would be this one. The force applied parallel to the incline necessary to move it up the incline. To move it up the incline at a constant rate. So acceleration is equal to 0. Velocity, though, is in that direction. There is the description of our problem. Now let's add in things that we know about this. We know that this is not all the forces. There's a normal force going in that direction. And there is friction. Oh, sorry. Get that in. There is friction, so that's going to be opposite the direction of motion. So we have a frictional force coming back over here. If we wanted to get nitpicky about it, we would point out that that is the force of kinetic friction because it is moving. Now, at this point, we should decide on what direction to make our x and y coordinates. And since we're on the ramp, we're going to say parallel to the ramp is x and perpendicular to the ramp is y. That means that our weight here can be broken into the component of the weight in the x direction, which is that portion, and the component of our weight, which is in the y direction, which is this component. And as always, the top angle is the same as this angle over here because they're similar triangles. All right, at this point, we can take what we understand, that the acceleration is 0, to say that the sum of the forces in the x direction are equal to 0. And so that means the forces that are going up the ramp, which is the applied force F, are equal to the forces going down the ramp, which is the force of friction and the component of the weight in the x direction. And then over in the y direction, we can say that the normal force, the force coming out of the ramp, is equal to the force or forces going into the ramp, which in this case is the y component of the weight. Alright, we are trying to solve for this, but to get that I need friction. And friction is, of course, the normal force times the coefficient of friction, plus our weight in the x direction. Now over here we have something for the normal force. It's equal to the y component of the weight, which is equal to the weight. I'm not breaking it into mass and gravity because they gave me a value for the weight, multiplied by the y component, so that's the adjacent side. So ka toa, that's cosine of my angle. I'm going to substitute this in here. I'm going to make my expression for w sub x. So F is equal to W times mu times cosine of theta plus W. If cosine gave me the y component, sine is going to give me the x component, sine of theta. And now we can plug in some numbers and actually get an answer. 5,400 newtons. Mu is 0.600, no units. Cosine of 10 degrees plus the weight, again, 5,400 newtons. I could have consolidated that out the front, factored it out, but it wouldn't save me much space. Multiplied by the sine of 10 degrees. Calculator time. 5,400 times 0.6 times 10 cosine equals, plus, open parentheses, 5,400 times 10 degrees, sine function applied to that, close parentheses, equals 4128.477279. We don't like that. We want to express this with a few significant digits. I would say since this had 3 and this had 3, we'll go with 3, even though that one does look like it has 2. So there's an argument for calling this 4,100, but I'm going to call this 4,130 newtons for my final answer. And we are done. Thank you for watching.